Welcome to ESOC, the Mission Operations Centre of the European Space Agency. My name is Mike McKay, and I'm one of the Flight Operations Directors. This main control room has borne witness to the excitement of 55 successful launches of the European Space Programme. On behalf of our 17 European member states, we fly missions that research our climate around planet Earth, look at our solar system, and probe the deep-flung reaches of our universe. One of the most exciting recent missions has been the beginning of the European Mars Exploration Programme with Mars Express, a spacecraft that is delivering data to unravel the mysteries of our neighbouring planet. Mars has fascinated mankind for thousands of years. Despite being half the size of Earth, it has a most impressive landscape, with the largest volcano in our solar system and a Grand Canyon that would stretch from New York to Los Angeles. Its surface features show that there was half of the planet covered by water for many thousands of years. Today it is a very dry, inhospitable planet whose temperatures drop to minus 90 degrees at night. The question is, if there was once so much water on Mars, was there life? As mankind has developed new technologies, we have pushed back the forefront of our knowledge. In the 1500s, with the advent of the telescope, the first images of Mars showed light and dark patches. This could be interpreted as vegetation and desert areas. With the start of the space age in 1956, it was naturally only a question of time before we went to Mars. So when Viking 1 reached Mars in 1976, the first images that returned were absolutely stunning. A human face on the surface of Mars. Could this have been left by an extinct civilization marking that they once existed? Or could it mark that the civilization still remained on Mars? Subsequent missions have shown this only to be a large geological feature, and life, if it exists on Mars, will be more likely in the form of bacteria or microbes. That's why the European Space Agency has built its mission Mars Express, equipped with high technological equipment, not only to probe the atmosphere and the surface of the planet, but also look up to 5 kilometers below the surface. The high-resolution stereo camera provided by Germany, which is flying on Mars Express, shows the surface in 3 dimensions, giving planetologists and geologists a new 3-dimensional look at the planet's surface. We've discovered processes that rip the atmosphere and the water into deep space, leaving Mars a very dry planet with a low atmospheric pressure, so low that water will only exist in ice or vapor form. We have found methane, a gas from volcanoes or living organisms, in connection with water vapor at 3 locations around the equator. This gives us great expectations that there could still be life below the surface. With the Mars Express radar, it's an international first that we can look up to 5 kilometers below the surface of Mars. This also shows large quantities of subsurface ice and potentially liquid water, which would only reinforce the expectations that life may exist there. As the NASA rovers are geological missions, it's a natural step that the next European mission to Mars will be to seek out these potential signs of life below the surface. ExoMars will be a rover that can drill 2 meters below the surface, remove samples, and analyze them with the latest technology to decipher if there is a sign of past or present life. ExoMars will be the first mission in the European Space Agency's Space Exploration Programme, which will involve robotic and manned exploration of Mars, which will hopefully lead to an astronaut setting his foot for the first time on another planet in the year of 2030. From what we have discovered today, it is clear there are strong similarities between Mars and Earth. Mars was once covered by huge oceans, much like our planet. Its axis of spin is inclined to the Sun, giving it seasons and dynamics that would have encouraged the existence of life. But the question still remains today, why is Mars such a dry and barren planet? Is it a result of a catastrophic climate change? Maybe instigated by global warming? Is our global warming a sign that at one stage our Earth may become a Mars? So the big fundamental question is not only, is there life beyond Earth? But perhaps, are we the Martians?